US Physics Olympiad, year 2012, F equal MA. First round. Problem 11. Solution for this problem you can find below this video in the reference of the description. As shown below, Lily is using the rope through a fixed pulley to move a box with a constant speed v. The kinetic friction coefficient between the box and the ground is μ less than 1. Assume that the fixed pulley is massless and there is no friction between the rope and the fixed pulley. Then, while the box is moving, which of the following statements is correct? Solution. Let's do first quality analysis. Suppose that initially angle between rope and the horizon is very small. In that case, force of tension approximately equal to μ mg, and μ is less than 1. It means that it's mostly like less than mg. And now suppose that angle is almost 90 degrees. In that case, magnitude on the rope almost mg, so it means that it's greater than μ mg, and the statement A is not correct. Let's check statement B. The magnitude of the friction between the ground and the box is decreasing. This could be true because during the motion angle is increasing and tension helps to reduce normal force, and this will reduce force of friction. So that's very close to a right answer. Answer C. The magnitude of the normal force on the ground on the box is increasing. This is obviously not true, because initially this magnitude equal almost mg, and finally it's almost 0. D. The pressure of the box on the ground is increasing. That's the same as statement C, so that's not true. Statement E. The pressure of the box on the ground is constant. That's again not true, because we just proved that initially it was mg and finally it was almost 0. Now let's prove our answer B by formulas. Suppose that the angle between a rope and the horizontal is theta, force of tension is T, force of friction is F, and normal force is N. Now let's write equations. So first we have tension multiplied by cosine theta equal force of friction, horizontal part. So for vertical part we have tension multiplied by sine theta plus normal force equal mg. And also we have a relation between force of friction and normal force. Force of friction equal μ multiplied by normal force. Now let's solve this system. First we can express normal force from second equation. We have this expression. Now we put this normal force in this expression for force of friction. And we can put this force of friction in the first equation. So this is the equation for tension. So we found that tension equal this expression. Now let's count what is normal force. Normal force is this one, and finally we can count what is force of friction. Force of friction, this one. Let's investigate behavior for all three forces: tension, normal force, and force of friction. If we look at this formula, we can say that when angle is close to 0 and increasing, tangent increasing, it means that force of friction always decreasing. For the same reason, normal force always decreasing. And the tension tension, if we investigate this function has a maximum between 0 and 90 degrees. So initially it's increasing, and after that it's decreasing. So it means that tension initially decreasing and after increasing. So that's the behavior for tension. And now let's see what happened here. A. The magnitude of the force on the rope is constant, which is not true. It's not constant. B. The magnitude of the friction between ground and the box is decreasing. Yes, that's true. We just investigated. And C, D, and E, they are not correct because of this formula. Normal force is always decreasing, which is not clear for C, D, and E. So correct answer is B.